Hello and welcome. OakGate's storage verification framework is comprised of two components, the controller and the appliance. All testing and analysis is performed through the graphical user interface of the controller. The devices to be tested are connected to the OakGate appliance. The appliance performs all the actual I/O on the drives and passes status and results back to the controller. The controller and appliance communicate over TCP sessions. We're looking at the graphical user interface of OakGate's controller. This is the first of two videos that will show how OakGate's storage verification framework can be used to benchmark the performance characteristics of data storage drives. In this first video, you will see how to run an existing automation script against the drives. This script is designed to test small block I/O, block sizes of 512 bytes through 32 KB. The results of this test will be a set of data and graphs, which will be reviewed briefly. In the second video, we will examine the captured data and graphs more thoroughly to analyze the I/O characteristics and performance of the drives. The controller has already connected to the OakGate V appliance, and the drives have been initialized. There are two SATA 2 drives, each with a 3 gigabit per second interface attached to the OakGate appliance. An 80 gigabyte Intel brand solid-state drive is attached to port 0B00. A 300 gigabyte 7200 RPM Maxtor hard disk drive is attached to port 0B01. The different I/O characteristics and performance of these two drives will help demonstrate the capabilities and flexibility of the OakGate product. To set up for the test, we'll first launch the automation tool by clicking the yellow automation icon. Next, we'll load the appropriate automation script. Click and then right-click SVF Auto Test, and then select Load Setup File from the drop-down list. To find the automation script that we want, we'll go to the Benchmarks subdirectory, and we'll load Benchmark Small Block I/O SATA version 4. We now see the several steps of this automation script in the center section of the display. The top label, Benchmark Small Block I/O SATA, is the test run ID. The other showing labels are the test sets. Each test set is comprised of one or more tests. Let's take a look at some of the details of this automation script. With the test run ID selected, look over to the right under the Setup tab. Notice that all of the HTML controls and CSV controls are selected. We want all test results in the form of HTML pages and CSV files to be saved as the testing progresses. The test results will be saved within a folder named the same as the test run ID. In this case, Benchmark Small Block I/O SATA. This test results folder will be located under the output directory specified above. Click on the Expand List icon next to the first test set, Initialize Disk. We see there is one test within this set. In this particular case, this is not really a test. Instead, this is a special action to precondition the drive for the testing to follow. This action, SATA Secure Erase, causes a SATA drive to erase all data on the drive. It is a single command issued to the drive, and the drive's firmware performs the actual erasure. The command can take from minutes to hours to complete. The SATA Secure Erase is included in the test run for the sake of the solid-state drive. The SSD has very complex I/O algorithms and state machines within its onboard firmware. Therefore, the state of the SSD at any point in time is only known by its firmware. The SATA Secure Erase effectively resets the SSD to a factory default out-of-the-box state. Thus, we can start our testing of the SSD from a known state. Click on the Expand List icon next to the second test set, Preconditioning 4K Random Writes. We see that this also has a single test within the set. This set is also a part of preconditioning the SSD for subsequent testing. The I/O performance of an SSD is at its peak immediately after SATA Secure Erase, but as we will see, this peak is very short-lived. To find the real-world performance of the SSD, we need to load the drive with enough data to achieve its normalized operating performance level. This test effects the needed normalization by performing continuous random writes for a period of 2 hours. The purpose here will become more apparent when we look at the data resulting from this test later in the video. Note that the 2-hour test duration is specified in the Performance Duration field of the Setup tab for this test. The next test set, Random Reads, is where the performance testing of the drives really begins. We click on the Expand List icon, and we see that the set contains 7 tests. Each test in the set does continuous random reads of a specified block size using 6 different queue depths. The block size varies from 512 byte blocks to 32 KB blocks, as indicated in the name of each test. The queue depth refers to the drive's onboard SATA command queue. SATA drives support up to 32 queued commands. Each test is performed using queue depths of 1, 2, 4, 8, 16, and 32 as specified on the Setup tab. Note that the OakGate driver keeps the drive's command queue loaded to the specified depth throughout the test. Each test runs for 6 minutes per queue depth, as specified on the Setup tab. A 1-minute warm-up and a 5-minute performance duration. Since there are 6 queue depths per test and 7 tests in the test set, each test will have a runtime of 36 minutes, and the total runtime for the test set will be 252 minutes, or 4.2 hours. The next 3 test sets operate exactly as the random read test set, with the only difference being the type of I/Os performed: random writes, sequential reads, and sequential writes, respectively. So there is no need to go into the details of these tests. Before we run the automation script, we have one more thing to set up. We have to tell the automation which drives to test. Click on the I/O Exerciser tab, and we will see the available drives in the green list at the bottom. Click on the first entry, and shift-click on the second. Then right-click and select Copy LUN Settings. Then click on the Automation tab, and then on the LUN Association sub-tab. Now click on LUN Path 0, shift-click on LUN Path 1, right-click, and paste LUN paths. We are now ready to run the automation. However, the overall duration is in excess of 18 hours. We want to actually run the automation as set up so that we have real data to examine at the end. So for this video, we will start the automation and then pause recording. Then we'll pick up when the automation is complete to look at the results. To start the automation test, first we'll click the Status tab so we can see testing progress. Click on the Benchmark Small Block I/O SATA label at the top of the automation script. Then click the Start button.